The program you're about to see is for the density in-place testing using a nuclear gauge. MDOT currently has around 80 nuclear gauges, most of which are the Troxler model 3440.
We won't cover radiation safety in this video, but we still need to be aware of the radioactive material that we are dealing with. The first question: what does ALARA stand for? The answer: as low as reasonably achievable. Next question: what are the 3 ways we can practice ALARA? The answer: time, distance, and shielding. This is the equipment necessary to run in-place density with the nuclear gauge: the standard block, a hammer, the gauge book, driving rod, and template. The standard block and gauge book are unique to each gauge and are not interchangeable from gauge to gauge. MDOT uses its own series of serial numbers to identify each gauge.
The Troxler 3440 is known as a direct transmission gauge, and this graphic shows the various positions the source rod may be put. The top position is the safe or carrying position, and is also the position the daily operating standards are run. The next position, in the first notch down, is called the backscatter position. Normally, the only time you would use this position is when you are checking the density of HMA overlays. The next 4 positions, 2-inch, 4-inch, 6-inch, and 8-inch, are also called the direct transmission positions. These positions are the depth the source rod is put into the material that you are checking for density and moisture.
This is the storage cabinet for the gauge used at all MDOT TSCs. The cabinet has proper labeling on it. On the top left is Caution, Radioactive Material. On the top right, all non-trained personnel must remain at least 2 feet away from cabinet. On the bottom left, a survey of the cabinet with the maximum number of gauges being stored in it at one time.
Somewhere on the cabinet will be NRC Form 3, a notice to employees.
On top of the cabinet is the sign-out book for the gauges. Whenever the gauge is removed from the cabinet, it must be signed out by the individual with the date, their name, the gauge number, location of where the gauge is going, the time it's signed out, and the time when it's returned. The gauge requires a warm-up period of 20 to 30 minutes before using. Once you turn the gauge on, you won't turn it off until you are through running tests for that day. MDOT always carries the gauge in the padded transport box on the passenger side of the pickup cab. Notice the standard block is also carried in the cab. The gauge is always padlocked with the cable during transport and on the job. The only time the gauge isn't locked is when you are taking a test or carrying the gauge to and from the truck. This is the scaler at the ready screen. The top line says ready and flashes between time and date. The second line says depth, safe position, which indicates what position the source rod is in. The third line says time, 1 minute, which indicates how long the test will be. All MDOT tests are run in the 1-minute setting. The last line says battery volts.
A full charge would read 8.0.
When the reading is down to 7.0, it will start to flash batteries low. We'll cover more on what to do when this happens later in the program.
When you reach the job site, the standard block should be placed on sound earth, which is anything except topsoil, and it must be at least 10 feet away from any large object, like a pickup, or a construction vehicle, or equipment, or a bridge abutment.
And it must be away from water, such as a mud puddle or a stream. Place the gauge on the standard block with the scalar end of the gauge towards the end of the standard block that has the metal end plate. It's good practice to slide the gauge to make sure it's between the raised edges. Pull the gauge toward you so it is tight against the metal plate. And tap the handle to make sure the source rod is secure in the safe position. Also, make sure the padlock is off the handle. Push the standard button located on the bottom row of buttons next to the yellow shift button. The gauge display will say standard count and will give the last saved standard count and ask, take new count? Press the yes button. The display will ask, is gauge on standard block and source rod in safe position? Press the yes button again. The gauge will start a 240-second countdown. While the gauge is running the standard, check the gauge transport book for the range of the moisture and density standard counts. This page consists of the MDOT and manufacturer serial numbers of this particular gauge and its date of calibration. Any gauge used on an MDOT project is required to be calibrated annually.
On the right side of the sheet are the upper and lower limits of the moisture range.
The moisture range is good for 1 year. Because of the decay of radioactive materials, known as nuclear half-life, the moisture standard range decreases each year as the nuclear gauge is annually recalibrated. The density standards will also change for this very reason. The radioactive material measuring density has a shorter half-life, so our density standards decrease more rapidly. Therefore, our acceptable range changes from month to month.
Find the current month you are in on the left side of the sheet and follow it across to the right for the lower and upper limits of the density standard count. In the lower right corner of Form 0582B, record the upper and lower standards for density and moisture in the space provided under Chart Standards. This slide shows the gauge after it's done running the standards and what the scalar display looks like.
For this example, MS equals 660 is the moisture standard, and DS equals 2435 is the density standard. To the right of the readings, the negative 0.5% and the negative 0.6% is referring to the average of the last 4 standards that were saved in the gauge.
If the two operating standards fall between the chart standards, record them under Operating Standards on Form 0582. If one or both of the values is not within the chart standards, run another standard. Try wiping off the standard block or moving to another area. If the problem persists, call an authorized person to come and look at the gauge. Make sure you press the Yes button if the standards are within the limits, and No if one or both are out of the limits. You are now finished running the operating standards, so return the standard block to the cab of the pickup. It's very important to handle the standard block with care. Damaging the surface of the block can result in the gauge standards not coming within range, and possibly result in the gauge needing to be recalibrated. Before you begin testing, you need to make sure that your gauge is in the correct mode.
The Troxler 3440 model offers 2 different modes of testing, soil mode and asphalt mode. The soil mode is used for granular and cohesive materials. The asphalt mode is used for recycled materials and HMA surfaces.
To get to the proper mode, press Shift, then Mode, number 8 on the keypad.
From the mode selection display, press 1 to select soil mode and 2 to select asphalt mode. Pressing 1 puts you into soil mode and the gauge returns you to the ready screen. Pressing 2 for asphalt mode requires 2 more selections. Select number 1 for % Marshall. Press No when the display asks you to enable % voids.
We are now ready to take our in-place density test. What you want to do is use visual inspection to determine where you take your test. We usually try to take our test in areas that appear to have the least compaction. The in-place density test is a spot check, so if tests in these areas pass, we can assume the areas that appear more compact would also pass. After visual inspection, we use the template to prepare the actual test site. The site does not have to be level, but it should be flat with few surface voids. Use the hammer to drive the drill rod to the depth at which you are going to take your test. Keep your foot on the template while driving the drill rod. This graphic shows the template and drill rod driven to the 8-inch depth. Notice that when the 8-inch groove in the drill rod is flush with the top of the handle on the template, you have actually driven the drill rod an extra 2 inches. This gives some space for any disturbed material to fall into the hole when inserting the source rod. Keep your foot on the template. Twist and remove the drill rod. If the drill rod is difficult to pull out, use a T-handle. Never wiggle or push the rod side to side when removing it. Keeping your foot on the template, use the tip of the drill rod to trace around 3 sides of the template. Remove the template and set the gauge within the scribed lines you made around the template. Squeeze the trigger and push the source rod down into the hole to the depth of which you are going to take your test. Make sure the source rod trigger is seated firmly in the notch of the index rod. Use your hand and tap the left side of the gauge so it is flush and tight against the driven hole. Press the Start Enter button, located on the bottom right of the scaler, to begin the 1-minute test.
Be sure to step back about 8 or 10 steps to avoid radiation exposure.
This graphic shows the gauge in a direct transmission test. The gamma source at the end of the source rod is emitting gamma rays in all directions. We are concerned with the gamma rays that are emitted towards the detector tubes.
The more dense the material, the lower the gauge will count the gamma rays. The less dense the material, the more gamma rays the gauge will count.
The neutron or moisture source is a fixed source, approximately in the middle of this gauge. This source also emits radiation in all directions. This source emits fast neutrons, and the gauge detects slow neutrons. The hydrogen in the moisture slows the fast neutrons down to a slow enough speed that the detector will count. The more moisture in the soil, the more hydrogen, resulting in more slow neutrons for the gauge to count. The higher the count, the more moisture that is present in the soil. When the 1-minute test is over, this is what the scalar display will show. %PR is the percent of Proctor, or percent of compaction. DD is dry density in pounds per cubic foot. WD is wet density in pounds per cubic foot. M is the weight of moisture in pounds per cubic foot. %M is the moisture percent. In this example, these are the displayed values on the gauge, which will be recorded onto Form
0582B.
DD equals 139.3, column 9. WD equals 146.2, column 5. M equals 6.9, column 7. And %M equals 5.0, column 8. We do not record %PR yet because we need to establish our maximum density first. To get moisture and density counts, press the Shift button, then press the Count button, button 1 on the scaler. Counts is labeled in yellow on the scaler, so we have to press Shift before we press Counts. The display on the scaler shows the density count and moisture count. Record the density count of 1547 in column 3, counts DC.
And record the moisture count of 92 under column 6, counts MC, or moisture count.
Obtain a sample of soil to establish the maximum density from the same site where you ran your in-place test. Procedures for each maximum density test will be covered in other programs. After you have established your maximum density below, record the value above as well in column 10, max density. Then we enter the same value in our gauge by pressing the Proctor-Marshall button located above the yellow Shift button. The display will ask, "Want to change?" Press the Yes button. The display will show a menu. To change the soil MD, press the To button. The display will ask, 1 stored value or 2 new value. Press 2 New value. Enter the maximum density value numerically. In this example, 141.5. The display now shows the complete max density, as instructed by the display. Push the Start Enter button. The display shows the max density, 141.5, and asks, "Do you want to save this value for later use?" Press the Yes button. The display requests you to pick a memory cell to save the max density in. The inspector chooses cell number 1. You may choose either 1 through 4. The display shows max density value 141.5, enabled, and stored in cell number 1. The gauge will return to the Ready screen. In order to get the percentage of compaction, first press the Shift button. Then press the Recall button, button 0 on the keypad. This will bring up the last test you just took and show the correct percent of compaction at the top of the display. The gauge divides the dry density of the in-place test by the max density you established and programmed into the gauge, and displays the results. Record the %PR value, which in our example is 98.4, in column 11, percent of compaction. The test is not complete until you record the stationing, distance left or right of center line, depth below plan grade, and the item of work. Check the back of Form 0582B for the requirements of the material to pass. In this example, S stands for sub-base that requires 95%. This would be a passing test. After completing the test, return the gauge to its padded box in the pickup cab and lock with the proper restraints. Never leave the gauge sitting on the grade or on the pickup tailgate unattended. It needs to be emphasized that the padlock should always be on the gauge and locked when transporting the gauge anywhere. The lock should also be in place with the cable restraint when the gauge is stored in the cabinet at your office. When going to lunch or leaving the pickup for any reason, the cab of the pickup should also be locked when the gauge is in it. When using the gauge and the batteries low appears on the bottom of the display, the gauge batteries need recharging. If you are in the field testing, a 30-minute recharge with the DC outlet charger of your vehicle will provide several hours of use. The gauge requires 12 to 16 hours of recharging to fully charge the battery packs. When recharging the gauge, connect the charge cord to the gauge by unscrewing the black access cover. Make sure the gauge says "Batteries charging" after it's plugged in. This is the Radiation Safety Program, Operating and Emergency Procedures, that is in the Gauge Transport Book. You, the inspector, are responsible for following the instructions as written on the memo. Also in the transport book is a list of contact numbers for all area density specialists and Lansing personnel. State police posts throughout the state are also listed in case of an emergency. This chart, which is in the Gauge Transport Book, shows typical readings given off by the gauge. It is also found on the Troxler website.